All right, so in this hour, we are going to discuss lead acid aircraft battery airworthiness. For those who not figured it out yet, my name is Chris Holder. I'm with Concorde Battery. I'm the Eastern U.S. Sales Manager. Now, with all of our presenters, we're going to give you our contact information here at the beginning and then also at the end of our presentation. Obviously, with the size of the audience that we have, we're not going to be able to field questions, but feel free to reach out to me either by phone or by email and let me know what you need. So today we're going to do a little quick introduction on Concorde and its history. We're going to discuss some battery technologies that are out there, battery safety, servicing and charging a battery. That's when we sort of get into the meat of the presentation. We'll talk about testing, conditioning, charging, things like that, how you clean a battery, which is far more simpler than you might realize, installation ability, eligibility, how to optimize your battery's service life. So Concorde is a family-owned company started by the Godbers in the late 70s. So we're in our 44th, almost 45th year, if my math is correct. We brought the recombinant gas sealed technology to aviation in the early years of our time. And the King Air was our first general aviation application. The F-18 was our first military application. It was the F-117 that really put us on the map back in 1986 when that picture was published. We got a phone call from the folks in charge of that project thanking us for all of our involvement, because at the time we didn't know what type of aircraft we were developing this battery for. And so we were OE, sole source on that aircraft until it was parked in the boneyard in 2009. And of course, general aviation applications, we have those across the board, as well as corporate aircraft, helicopters, pretty much across the board. And we also do have some heavy iron applications as well. We also have a new facility in Austell, Georgia, which is essentially Atlanta, right off the southern approach to Charlie Brown Airfield there in Atlanta near Six Flags, if you're familiar with that piece of ground. So we've got factories on both ends of the United States now. Now, you're going to see this a lot through the presentation, the component maintenance manual, that black book, that we refer to essentially as our Bible. Everything that you need to know about maintaining batteries, charging batteries, caring for batteries, all that is included in the CMM. So you're going to see that, and I'm going to remind you through this presentation that you need to refer to that. You can either pick up the paper copy, which comes in every container with a battery in it, or you can go to our website, concordbattery.com, and look it up there as well. Our website is new, very clean, easy to move around, aircraft applications, all kinds of information in there. So please go there as well if you don't have a paper copy. So the technologies that are out there in our industry right now, obviously lead acid batteries, NiCad batteries, which became very popular in the 60s, and then lithium ion, which is poked its head into our industry the last 5 or 6 years. So let's take a moment and discuss LIF. Now, Concorde's a lead acid battery company, but we've actually been building lithium ion batteries as test articles for the Navy for the F-18 for a decade now. So we're very familiar with the technology. It has some obvious advantages. It's essentially half the weight and a third more power, which is kind of the holy grail when it comes to aircraft manufacturing. You know, I've always said that if an aircraft manufacturer, if I go to them and say, look, I've shaved a couple of pounds off of this battery and I haven't changed the profile, I get to play golf for free all summer long. If I shave half the weight, they name children after me, because it's a really big deal when it comes to weight. But there's obviously some concerns out there. You know, back in May of 2011, when this came to light for everybody, the Dreamliner was parked at the gate at Boston Logan. It was not hooked up to ground power. The batteries lit up. Fire department was there in less than 2 minutes. It took them a couple of hours to extinguish that fire. It's very hard to extinguish that fire once it gets started. So there are obviously concerns there. It's also incredibly expensive, and given its lifespan versus that, you know, what's it going to do to the industry? It's very difficult to ship a lithium ion battery. Disposal's also kind of up in the air right now. They are recyclable, but it's extraordinarily expensive. And is the industry ready for it? I mean, there's applications out there right now, so we'll just kind of have to see where lithium ion goes as we move forward. So let's talk some battery basics. The old original flooded style batteries consume water through electrolysis. That water must be replenished at fixed intervals or where it's necessary. So chasing those fluid levels was always an issue and contributed to shortening the life of a battery. Now, gel was the first non-spillable carrier for acid in our industry for these batteries, but what we discovered very quickly was that voids develop in that gel. Think of a piece of Swiss cheese, and wherever there's a void resting up against the plate, that part of the plate cannot charge. And you really only need your battery for two things: to start the aircraft or to provide essential power to get you back down on the ground if you lose your generating system. So you couldn't meet minimum capacity with those voids. So gel came and went very quickly. And then you got the seal technology. Now they're known by a lot of different names. Recombinant gas, RG, which essentially refers to how these batteries work. You know, our part numbers begin with RG. And that simply explains that these vent valves are designed to recombine that gas back into the AGM mat, so you never have to service the fluid levels. So they're known as AGM batteries. It's very common. Valve regulated sealed lead acid batteries, VRSLAs. Slabs is also common, sealed lead acid batteries. So you've got some photos here. Let's focus on the photo on the left. You've got two cells in that picture. The cell on the left is a sealed cell, the cell on the right, a flooded cell. Let's deal with that one first. The brown line represents the plate. You can see the plate doesn't go all the way to the bottom of the box. That's because in a flooded battery, number one, you have to have space around those plates to allow that electrolyte to slosh around in there. And then you can't run the plate all the way to the bottom of the box. It needs to set up on what's called a mud rest, because over time, that electrolyte washes the active material off the plate and it begins to settle at the bottom of the cell box. And if it builds up too high over time, it could actually touch the bottom of that plate pack and short it out. So they've got to sit up on that mud rest to prevent that from happening. So smaller plates, not as many plates in a flooded battery. So the cell on the left, that's a sealed cell. And you can see that brown line representing the plate runs all the way to the bottom of the battery box. That's because we don't need the mud rest, because the acid resides in what's called an absorptive glass mat, kind of a spongy square that we soak to a little better than 90% capacity, and then we sandwich those between the plates. So you don't have the free electrolyte in the battery box like you used to. So you can run those plates all the way to the bottom of the cell because you're not going to have that mud issue. So more plates and bigger plates, which gives about a 20% power increase over a standard flooded battery. Now, all of our 24-volt batteries are known as platinum series batteries. You have the option with the smaller 12 volts to get the stock sealed or the platinum series. But what that simply means is there's a few more plates per cell in each one of those batteries. And what that does is it gives you another 18% more power. So you're talking roughly 38% more power in a sealed platinum series battery. Quite a bit of a power difference. Now, this is a cutaway of one of our more popular turbine batteries, the RG380E44, and you can see the cutaway showing the cell packs, the gray walls, or the cell dividers. But those copper terminals, the Elcon style connected terminals, that improves your high rate discharge, makes it a more efficient energy starting. And then your intercell connections, this is a big difference here. There's really only two ways to manufacture a battery. You can either do it in an automated process, or like Concorde, you can build them by hand. And we are one of the last battery manufacturers on the planet that still does it this way. So if you're building them in an automated process, you reach down where you see the cell wall and you spot weld those two cells together. And that spot weld is about the size of a pencil eraser. And what happens over time is, because these batteries live in a vibratory environment, especially in the helicopter industry, and those spot welds can break or crack. What happens more often is the vibratory environment will allow that spot weld to warble out that hole just enough to allow those fluids, even in a sealed battery, allow those gases to walk back and forth between those cells, and it will actually neuter them and render them ineffective. So what we do is we go over the top of the partition. You can see that intercell connection there. If you put your thumbs together, that's about how much lead that is for one cell connection. It's a much more efficient energy in, energy out type of situation, much more robust design. And then the electrodes, that's your quantity and surface area, determine the battery capacity. Thickness affects the high rate discharge, which is engine starting. So all these things add up to a very robust battery that performs extraordinarily well. So let's talk about temperature versus power. Now, in the automotive industry, they have a marketing term called cold cranking amps, which was popularized by the old Die Hard commercial. If some of you are old enough to remember, back in the early 70s, there was a Die Hard commercial. Guy's out on an ice pack. He's got 7 cars connected to one battery with a plunger. He says he's going to start all these cars. And then he says, but before I do that, I'm going to turn the lights on. And everybody thought that was the most amazing thing in the world. Ran down to Sears and bought a Die Hard battery. Well, the truth of the matter was, had he not turned on the lights, the energy transfer is what warmed up the battery to allow it to kick off the car. So if he hadn't turned the lights on, he probably wouldn't have got the car started. Temperature is everything when it comes to batteries, and it's demonstrated right here with a RG380E44 number. So on the aviation side, IPP and IPR are the ratings. Initial peak power measured at roughly 0.3 of a second when you hit the switch, and then IPR, initial power rating, which is measured at 15 seconds down the line. So if you look at that first column at roughly room temperature, at IPP, you're going to get 1,350 amps out of that 44. And at IPR, 15 seconds down the line, you're going to get about 1,000 amps. But look at the next column. When it goes to 0 degrees, look at the power fall off. And then again at minus 22, it falls off again, but not quite so much. And the reason for that is the cold weather. So lead acid batteries typically operating at roughly room temperature is their ideal performance range. We have spent a tremendous amount of time and effort in these cold conditions developing these batteries to work to the point where at minus 20 and below, we operate better than NiCad batteries. But the point of the slide is to help you understand that temperature matters. And if you're going to be operating in cold conditions, you need to have heater blankets. You need to be willing to get the battery out of the aircraft, put it in the FBO office, take it to the hotel with you, anything to keep that battery reasonably warm, because temperature affects battery performance. And in the world where most of you operate with turbine engines, hot starts are a big, big no-no. So this is an example of that. Y'all remember 5, 6, 7 years ago, there were some doctors down at the South Pole who were ill, and somebody had to go get them. And so Ken Borak took that Twin Otter down there and pulled those folks out. That battery was cold soaked to minus 60 that night, fired up the engines, no problem, the next morning, and got everybody out of there. So Concorde really is the preeminent cold weather operations battery. When it comes to safety, there's not a tremendous amount to know about batteries, but they are very important points to make. First of all, these batteries are heavy. Turbine batteries are anywhere from 60 to almost 100 pounds. Several years ago, we added straps to the top of the battery, which will carry up to 8 times that battery's weight. Makes it a little bit easier to move these batteries around. If you're not going to use them by the straps, please put them on a cart. If you're going to move them around any distances in the hangar, put a pair of engine gloves on your hands. You guys work in an environment where you've got a nice sheen of sweat on your hands all the time. So before you grab that battery, put some engine gloves on them, give you a little bit better grip. And then when you're dealing with Elcon style connected batteries, if you are moving them around, make sure that Elcon cover is covered with a dust cover, or at the very least, have the Elcon facing outboard so that you don't touch those Elcon connectors with your belt buckle. The stories are true. There are folks that have welded pictures of their belt buckles to their bellies over the years. So be very careful when you're moving those batteries around. Again, refer to our component maintenance manual for detailed instructions about things like this, and it'll give you all the information that you need. You can find that either in the paper book or on our website at concordbattery.com. So should you or should you not store a charged battery on the ground or on a concrete floor? Now, my grandfather was a fighter pilot, World War II, and he taught my dad, and my dad taught me, son, Always put a battery on the 2x4 before you set it in the garage, or that concrete will suck the energy out of it. And that's really not true. Where that sort of came from, in the old days, there was a company called Rebat, as well as some other companies, but they had rubberized porous containers and they would leach. And the issue really isn't, obviously containers now are plastic or metal, but the issue with battery storage fundamentally is temperature. You want to store batteries in a cool condition to slow down self-discharge, because they all self-discharge over time. For instance, you could take a battery, sit it in a refrigerator, come back a year later, it will have lost 2 or 3/10 of a volt. You sit it out on the ramp in the middle of July, where I live in South Carolina, and you can bleed the energy out of it at a very, very quick rate. So temperature is everything. So make sure 68 degrees or a little cooler is where you're storing these batteries, so that they don't self-discharge. Also, as an FYI, you see that shorting spring on the Elcon connector. This was sent to us some years ago for some testing. And obviously, this is someone who spent a lot of time working on NiCad batteries, because with NiCads, before you ship them, you obviously have to zero out the volts. You do this to one of our batteries, and you've turned it into a very expensive boat anchor. So just make sure that you're not doing that when you ship these batteries. They ship air, ground, or sea, hazmat free. So Concorde VRLA batteries may be serviced in any battery facility, including NiCad service facilities. VRLA batteries are sealed to prevent cross-contamination of the electrolyte. Back in the old days, back in the 60s in particular, in the military, lead acid batteries are pink, and they still are to this day, to differentiate them from NiCad batteries, because you service them in the same room, get them close, they cross-contaminate, and it basically neuters those batteries. Well, these batteries are all sealed now, so that cross-contamination does not happen. I still go to shops where there are 2 separate battery rooms, and that's fine if that's the way you want to do it, but just know that you don't have to do it anymore. And again, you can look at our CMM for details on that as well. Concorde connector maintenance and terminal inspection. You need to look at these Elcon connections in the MS3509 connector fairly regularly, and you're looking for a couple things, and there's a couple things that you need to do. You need to clean and lubricate every 500 mating cycles, the contact pins, the engagement socket, retaining pins, the mating plug, the worm screw. You want to check the contact sockets roughly every 500 mating cycles. As these sockets wear, that springy compression force kind of goes away, and you don't get a good mate. So you need to look at that every once in a while. Also, make sure that when you are mating the MS3509, that the plug stays horizontally aligned with the battery's receptacle, because if you do misalign that, you can cause excessive shear force that gradually wears down the retaining pins inside the engagement socket. So just a few things to keep in mind when it comes to maintaining and inspecting the Elcon connectors. So putting a battery into service, known as commissioning. There's a big difference between flooded batteries and sealed batteries. We stopped making flooded batteries about 6, maybe almost 7 years ago now. But when you put one of those into service, how do you do it? Well, take it out of the box, you fill it full of acid, you let it settle, shake around a little bit, put some more in there. And then typically what happens is that battery gets charged for 3 or 4 hours, goes in the aircraft, and away they go. And it is enough to start an aircraft. But if you do that for the first charge on a flooded battery, which is called a forming charge, you've cut that battery's life by half. Okay, it's a 14 to 16 hour process, the forming charge. And then it has to be capacity tested, because no flooded batteries that Concorde made or my friends at Gill still make are airworthy out of the factory. So they've got to be capacity tested. And then you got to spend a few hours charging that battery back up. So you're looking at roughly a day and a half to properly commission a flooded battery. And in the culture we live in now, that's really just not acceptable. So with a sealed battery, you simply take it out of the box, check the open circuit voltage, and put it in the airplane. That's 20, 30 minutes tops if you're close enough to the airplane. So it really makes a big difference how you put these batteries into service. You know, our batteries are airworthy out of the factory, and it's not a lot test. We don't pull one battery off of a pallet and test that battery. We test every single battery, not once, but twice before it goes into the box and it comes to you. The one thing I would ask you to do is that when you get new batteries into your shop and you open up the box, the first thing you want to do is check the open circuit voltage of these batteries. If they're anywhere down near 25.75 for the 24-volt batteries, you need to put a boost charge on them. If they're down around 25.5, they need a boost charge. If they're anything below that, take the time to give me a call. We'll make sure that you get a fresh battery, because that battery's been sitting on the shelf. It's probably sulfated. It's not going to last the appropriate amount of time. So we want to make sure that you're using batteries that are fresh, fully charged, and ready to go out of the box, brand new. Services and charging, always refer to the instructions for continued airworthiness, the CMM, the owner-operator manual. The activities that you will find in that book consist of checking the open circuit voltage, different charging methods, obviously cap checking and how to do that to determine airworthiness. If it fails cap check, a conditioning charge is in order, and we're going to discuss that here in just a few minutes. Also, physical inspection of the battery, the terminals, the connectors, things that we just talked about. So all that you can find in those manuals or on our website at concordbattery.com. So the open circuit voltage of a fully charged lead acid battery is 2582, 2583. It indicates state of charge of the battery. It does not indicate airworthiness. That's state of health. So state of charge and state of health are two different things. In point of fact, the battery in that picture would come nowhere close to meeting minimum capacity. There's a lot of sulfation in that battery, but the healthy part of the plates took a charge, and that's what the voltmeter is telling you. Capacity tests do not wear batteries out. So if a battery comes into your shop and you're uncertain of its history, charge it up, do a capacity test. It's the only way to determine airworthiness, the only way to determine state of health. Don't use the voltmeter to do that. And in point of fact, if you look here, a 12-volt battery or a 24-volt battery with that much voltage in it is in a 25% state of charge. So keeping batteries charged fully is what helps them achieve their maximum lifespan. Different types of charging methods, constant potential, that's the type of charging that you do when you're charging up anything in your life on a daily basis, your phones or whatever it might be. Constant current charging, which is that conditioning charge method, is what you use to recondition a battery, which we'll talk about in a few seconds. And then you've got maintenance, pulse chargers. See the black box there? That is a battery minder made by VDC Electronics in Huntington, New York. It's the only maintainer we recommend. They allowed us to work with them to develop a maintainer with the right voltage set points, cutoffs, float voltages, so that may be left on the battery for extended periods of time. So if aircraft's going to be down for a while, if you've got batteries on the shelf that you know are going to be there for a while, use battery minders. They really do help extend the life of batteries that are not used very often. Obviously, if you fly at least once a week, you go an hour at least when you go in between starts, you're going to be fine. In the helicopter environment, oftentimes, especially the medical guys, you have 8, 10, as much as 12 starts per day. And some of those flights are as little as 2 or 3 minutes from the helipad at the hospital back to the station. So battery minders can really make a difference when it comes to helicopter batteries coming back into the barn at the end of the night, hooking up a battery minder, getting that battery recharged, ready to go for the next day. It is one of the more critical points of this presentation for you as helicopter operators to realize that very often you do not get batteries fully recharged. It takes about an hour in flight to fully recharge a battery once you've started. It takes about 15% out of the battery to charge or to start a turbine engine. So battery minders can become very much a good part of your maintenance regime in helicopter operations. And then the 2 red units you see there, those are charging and testing units from our sister company, Advanced Power Products. So you can go to their website or go to Concorde Battery or give me a call, shoot me an email, and we'll get you some information on those units. They're extraordinarily easy to use. The BC8000 up at the top right weighs 14 pounds. It's very easy to move around compared with the old superseders that sit on a lot of benches out there to this day. So at what time should you boost charge an inactive lead acid battery to prevent it from sulfating? Well, it's not really a time issue, it's a voltage issue. When batteries get down to either 1275 or 25.5, they need to be boost charged. Any opportunity for a battery sitting in some state of discharge, that sulfation is going to start to develop. So check those open circuit voltages. If the batteries are living in a hot environment, they're sitting on the shelf, you need to look at them more often. And that's what this graph represents. You can see on the left, when the temperatures are cold, the boost charging intervals are quite long. But as you move into hotter temperatures, you can see that the boost charge intervals become fairly common. So again, temperature means everything when it comes to inactive batteries sitting on the shelf. Discharge rates, big difference between flooded and sealed batteries. Flooded batteries lose roughly 25% of their energy every 30 days at room temperature, but you can see when the temperature gets really hot, you can drain energy out of a battery very, very quickly. The great thing about sealed batteries, RG batteries, they discharge 3 times slower than a flooded battery, which means you stand a lot better chance getting your aircraft started if it's been sitting for an inordinate amount of time. Is it okay to fast charge a lead acid battery? This is where we differ with our friends at Gill. They don't particularly care for this. We do. In fact, our batteries can take up to 8 times the C1 rate, which for a 42 amp hour battery, that's 320 amps. Now, you're not going to find a charger that's going to give you that kind of energy. Typically 25 to somewhere near 50 amps is about the most you can find, but crank it up, because the faster you get the energy in that battery, the less time it has, less opportunity it has for the plates to begin to sulfate. The one key here to all this, and it's in bold, you must control the voltage. The difference between aviation batteries and automotive batteries typically is the thickness of the plates. Automotive batteries have very thick plates. They're designed for abuse, thousands and thousands of starts. Aircraft manufacturers want the most power I can give them out of the smallest footprint that I can cram it into. So the way that we adjust is we make thin plates. More plates you get in a battery, the more powerful it is. But the downside is there's some fragility there, okay? And you really need to control that voltage. You can actually warp or even melt the plates if you do it for too long. So make sure that you control the voltage when you're charging those batteries. Capacity test minimums. The FAA says 80%. In 4313-2B, they do talk about 85%. Concorde's minimum battery capacity requirements for return to service is 85%. And I get the question reasonably frequently, why is there a difference? And it is no more complicated than an added margin of safety for you as an aircraft operator. Sometimes those minutes can make all the difference in the world. So capacity testing a battery is fairly simple. Going to obviously have that battery fully charged, and then you're going to discharge it with an appropriate bench unit at that C1 rate, which is on the sticker and on the front of your battery. So let's take that battery we've been using, the 380E44, that's a 42 amp hour battery. You're going to discharge the battery at that rate. If you make it to 51 minutes, by the time you get to the endpoint voltage of 20 volts for a 24 volt battery, you're at 85% capacity. Okay, obviously if it goes 54 minutes, it's higher. It's 90%, it gets to an hour, that's 100% capacity. From time to time, you will see batteries go 102, 103, 104% capacity. These things determine the intervals for the next capacity check. And that leads me to this quote from our CMM: the capacity check interval specified above are general recommendations suitable for most applications. The intervals can be adjusted for a specific aircraft or fleet once average battery life is established. So typically with a turbine battery, you're going to test that battery at the 12-month mark, and then based on that pass, if it passes above 90%, the next one's at 6 months, 85 to 90%, it's 3 months. But in Concorde's Technical Bulletin 14, it allows you to extend or adjust that cap check interval. So, for example, if you have a ship that you're getting ready to put the third battery in, okay, the first battery lasted 3 years and then failed at 3 years and 6 months. The second battery lasted 3 years, failed at 3 years and 6 months. So for easy math, the average lifespan of those first two batteries was 3 years. So when that third battery goes in that ship, the first capacity test is at 3 years, okay? So what this does for long-term Concorde operators, it allows you to adjust those intervals where you don't have to touch that battery for the first time for an extended period of time. Now, obviously, if flight profiles change, then you need to go back to the original guidance for capacity testing. Scheduled inspections, how often do you perform these? Well, as I said earlier, your first cap check's at 12 months. If it's above 90%, then it's 6 months. 85 to 90% is 3 months. If your aircraft manufacturer wants you to do this more frequently, you have to accede to the aircraft manufacturer's wishes. But as always, refer to the component maintenance manual for whatever type of battery that you're going to do a cap check on, or go to concordbattery.com, go to battery docs, and you can find that information there as well. Sulfation, this is what it looks like. The picture on the left are new, healthy, spongy plates, and the picture on the right is a picture of those hardened lead sulfate crystals. So any part of the battery plate that's discharged, that lead oxide starts becoming lead sulfate, and it acts like a barrier, and it just simply won't allow a charge to get through it to the healthy part of the plate that is still inside in the interior of that plate. You know, I use this, if you've been to our seminars the last couple of weeks, you know, if you have a slice of bread that's really moldy on the outside and you pull that mold off, the inside of that slice of bread typically is still healthy. And plates work much the same way. So we've got to get rid of that sulfate if we want that battery to continue to be able to be used. Now, these are all the things that it's caused by. Leaving a battery discharged for a long period of time before recharging it, that repetitive undercharging, those short legs that some of your ships are flying, parasitic loads that will slowly drain the battery, extended dormant periods without boost charging. The longer you let the conditions persist, the harder the sulfation becomes and the more difficult it is to reverse. You get it to a certain point and you simply can't recover the battery, and it's time to scrap it. So what can be done to correct it? Well, it's called a conditioning charge. We're going to talk about the parameters, how you perform one, and again, all this information is available in the CMM. So the only time you're going to do a conditioning charge is when it fails capacity test, okay? Because it will tell you in the manual that you want to discharge the battery down to the endpoint voltage. Well, you're already there because that's what a cap check does. So from that point, what you're going to do fundamentally is set up the charger for a constant current charge. You're going to take 1/10 of the C1 rate. So that 42 amp hour battery, 4.2 is your current rate that you're going to set up on the charger. And then you're going to turn the volume up as high as it'll go on the charger, which is typically 36.2 volts on the voltage side, to allow that battery to slowly climb to as high as 34 volts for a 24 volt battery at the end of this 16-hour process. And that is how long this takes. Now, the manual tells you if you don't want this going on overnight in the hangar, you can break it up into 2 8-hour segments. Every 4 hours or so, go over and touch the battery. For the end of the process, the battery is going to warm up, but what you're looking for are hot spots. If you feel a hot spot, chances are you've got a bad cell in that battery. But I cannot emphasize enough how effective conditioning charge procedures are. Now, there's a trade-off. People ask all the time, does a conditioning charge shorten the life of a battery? It does put some wear on the battery, but the only reason you're doing this is because you're trading off scrapping the battery and buying a new one to give yourself another 6, 8, 10, 12 months of battery life, okay? So remember, the cap checks do not shorten the life. If you're not sure of the state of health, do one. But the only time you're going to do this is when a battery has failed capacity tests, and it is extraordinarily effective. The remedies to prevent sulfation: charge batteries when they're in any state of discharge. Are you tired of hearing that yet? Good, because that's the key. Eliminate those parasitic loads. Use a battery minder if charge time is too short. or your aircraft's going to sit for a while, or you've got those multiple starts every day. You need to get that energy back in that battery overnight while the aircraft is waiting to be utilized the next day. When should you check the aircraft's charging voltage? Annually, in the summer, in the winter? Well, the answer is annually. And here's the chart. 13.8 to 14.2 is the range for a 12-volt battery. 27.6 to 28.4 is the range for 24-volt batteries. If you're willing to change your aircraft charging system twice a year, you can get a little bit more life. In the wintertime, you want to set it up to the high end of that range that I just described to you. If it's the summertime, a little lower, on the lower end of that range. This will actually give you a little bit longer battery life. Now, we've been talking a lot about dead batteries, and the issue is why. And in the last decade or so, parasitic loads have become quite rampant. Aircraft are getting more complex. They have more toys and whistles and bells in them. So the opportunity for parasitic loads is pretty big. So if you have an old style or a traditional terminal style battery, obviously it has to be connected to the aircraft to check for parasitic loads. And if that type of battery is connected, you can get to the terminals. But in the Elcon, the turbine style batteries, when it's connected to the aircraft, you can't get to the pins. So this little gizmo here, we call a parasitic load test adapter, which you can obtain from any of your Concorde distributors. And simply what you do is disconnect the aircraft, slide this onto the Elcon pins, reconnect the aircraft through it, and then you have these leads for your digital multimeter with everything turned off on the aircraft. Set the setting on the multimeter as high as it'll go in case you got a large parasitic load. You don't want to damage the battery, and then simply turn it down. And if the digits or the needle starts to move, you've got a parasitic load. Now, it's not going to tell you where it is. And this is what I spent a lot of time doing in the Marine Corps and the tail boom of Cobra helicopters, checking cannon plug pins for parasitic loads. But it gives you an idea of where you need to start looking. The worst thing in the world you can do is have a battery fail early, make the assumption it's a bad battery, stick another one in there, and then it fails early as well, and the frustration mounts and the wallet gets lighter. So if you have an early failure, this is one of the first places that you need to go to check and see what might be the issue. So is a helicopter airworthy with a dead or a discharged battery? It's not a trick question. It is not, only if it was certified with one. And I don't know many, if any, that were. So here's a critical issue, recharging dead batteries. If an aircraft with a dead battery is started with external power, also known as a jump start, how long does it take to recharge the lead acid battery with the aircraft generating system? Well, the answer's in the watch, about 3.5 hours. And this is a scenario where you can get yourself into trouble. Got a helicopter on the ground, passengers, absolute dead battery, calls for a line start. He's up in the soup a few minutes later, and the generator lets go. If there was not enough energy in that battery on the ground to close the relay, then that battery received no type of recharge. And essentially, there's no essential power to help him get back down out of that situation. So if you don't hear a lot today, hear this. Don't jump start batteries, aircraft batteries. Take the time to either get that battery recharged or get a new battery and put it into the aircraft. It's just not worth the risk. So discharge minimums, how low can you go before you damage a battery? Well, the answer is C. You don't want to get below 9 volts for a 12 volt or 18 volts for a 24 volt. You get down around those numbers, below those numbers, you can get what's called reverse polarity, and it can happen very quickly. So if you find a battery in that state, do a capacity test. Charge it back up, obviously, and then do a cap check to see if it's been damaged. So if an aircraft battery has been dropped or otherwise, what's the acceptable type of damage? Well, the pictures that you see there, that obviously doesn't work. But if you have a crack in the case, or if you have one of those white lines in the case, you know, when we were kids, you take a colored piece of plastic and you bend it. You get that white crease. If you see that in the case, that's an unairworthy situation. That battery has taken a tremendous lick to get in that condition, and in all likelihood, something internally has been damaged. Now, if you see this, we're in good shape. This is how sealed lead acid batteries are supposed to operate. Concorde sealed lead acid batteries carry a positive 1 psi inside of them. And sometimes when the vent valves burp, at altitude or otherwise, you can get that concave or that bulging look, okay? It can take up to a week for this to readjust itself, okay? So don't panic. If you want to call me and talk about it, we will, but just know that if you see this, your battery's operating properly, and give it up to at least a week to readjust itself to its normal shape. Cleaning batteries, pretty simple. A rag and water, no solvents, don't need them. Just wipe it down before you're gonna do testing or anything like that. And then Concorde's battery eligibility list is located at concordbattery.com. It's very easy to navigate. It's under the knowledge base and applications. There's a number of different ways to install our batteries. AC 2327 essentially applies to the piston GA side of things. So if there's some of you out there that do touch piston batteries, have a look at AC 2327. It's a great read. Also mods, STCs, service bulletins, obviously TC'd out of the factory, 337, field approvals, things like that. So there's a number of different ways to get it done, but you can find that information at concordbattery.com. Now we have some new STC approvals, the Leonardo AB139 and AW139. We've got some upgrades there, obviously versus NiCad's lower acquisition costs, reduced cost flight hours, no memory effect. They ship hazmat exempt, which is very important, and they're also fully recyclable. Same for the MD series. This has been a very popular conversion. Again, same issues apply, lower cost of acquisition, no deep cycling, no water replenishment, hazmat exempt, and they are fully recyclable. But this is, for the MDs, this has been a really popular STC. So go on our website and check out the info on that. And then again, another one with the AS365N series, the EC155s, new batteries there as well. Again, upgrades in power, a lot cheaper to operate than the NiCad alternative. This is a very recent one for the Enstrom helicopters, the 480 and the 480B. This replaces the gill. It's a drop-in replacement. It's a power upgrade, much more reliable. Not going to have the issue with the hot starts because these batteries are going to take you all the way to the end. And then the S92 as well. Same situation there, drop-in replacements, reduced cost per flight hour, hazmat free, great power delivery, great life, good conversion there as well. So our battery disposal, lead-acid batteries are 100% recyclable. So either check out the website there, calltorecycle.org to find the nearest recycling center where you are. Local automotive parts houses will typically take batteries back and give you a couple of bucks to recycle them. But our batteries are 100% recyclable. And this is our sales team. Domestically, of course, you see me there at the top right. I cover the eastern U.S. Mike Abrams covers the western part of the United States from the Mississippi West. Bob Burkle's in Texas, and he covers Canada, Hawaii, and Alaska. Dave Chavone lives up near White Plains, New York, so he covers the Northeast. And Dave Vega lives out in California, so he covers the Western Seaboard. Claudio Fonseca, you see twice on our list because Claudio lives in South Florida, and he covers the southern tip of Florida, but he also covers Mexico, Central, and South America. Gary Vickery is our good friend over in the UK. He lives in Wales. And then Tony Vella, who recently came to the team about 2 years ago, he is in Australia. Our customer service team is second to none. Shelly Johnson is at our facility in Austell, Georgia, and Atlanta. Gloria and Ashley are out west in West Covina. For you East Coast folks, this gives you a little bit of an expanded window to work with in terms of hours. If it's 6 or 7 o'clock here, you can still get a hold of somebody on the West Coast. But these ladies are very good at what they do. In fact, they're the best that I've ever worked with in the 25 years that I've been in this industry. They pick up the phone. We, in fact, love for folks to call us at Concorde. We actually pick up the phone, love to talk to you, help you, assist you in any way you can. Send them an email. You'll hear back from them very shortly. All right, so let's summarize real quick and we'll be done. Open circuit voltages do not equal state of health. Okay, OCV and state of health, not the same thing. Capacity tests are the only way to determine aircraft air or battery airworthiness. Don't jumpstart a battery, an aircraft battery. Take the time to get a new box of lead or get that battery recharged. Keep your batteries fully charged without overcharging when they're not in use. That's the secret to all of this. And always refer to that CMM for instructions and guidance. So with that, that's all I've got. Thank you so much for listening.